precisely model, analyze, and design buildings to withstand the impact of seismic load and ground shaking. Meanwhile, the Indian Standard IS 1893 sets resistant structures, providing guidelines on seismic design principles and load calculations. So if I'll move to the code design and represent the maximum expected lateral force that the building's structural system must resist to maintain its integrity and safety. Or you can say it's a total horizontal seismic force as sorry guys for inconvenience. I'll directly move to the software part. I think there is some technical glitch again. So I have created this structure for this webinar purpose. Let me start recording. Yeah. So I'll show you uh, how you can assign the earthquake load on a structure. First, I'll show you. You can see uh, to assign the earthquake load, first you need to create the definition. So you will go to this definition option. Here you can see. Then you will click here on the plus button. I have already assigned on this structure. So I'll show you another structure and will tell you how you can assign. So just go to this definition option. I have created this structure, created the geometry, assigned the material, and also assigned the support. I'll directly start from this loading part. Just go to here on definition option, click here on plus button. Move on where it says seismic definition. Click on add button. So you can see this window will open. And these data you have to fill in. Just select the code. As I am using IS 1893 part 1. So either you can enter these data manually or you just go to this generate button. Yeah. So this window will pop up. You can see different options like zone factor. Either you can select the city. Yeah, so this window will open. Either you can select the city where you are going to construct your structure, or you can select the zone. You will select the zone. Suppose I am taking the zone 5. So the zone factor automatically taken by the software. Response reduction factor, you will choose your reduction factor, your frame time accordingly. The response reduction factor will be taken by the software. Just I am selecting RC building with a special movement frame as of now. And importance factor. Importance factor depends on the building type. If you are going to create or important structures like hospital, then it would be more like, if I'll select the important buildings, you can see the importance factor would be 1.5. If you will select the residential or commercial buildings, then the importance factor would be 1.2. Similarly, if for all other buildings, it would be 1. As of now, I'm taking all other buildings. Select the soil type. I'm taking the medium soil and structure type. Damping ratio, 5% by default. That is what IS 1893 recommend. And then you will click on this generate button. Click on this add and close. So here on the right hand side of the screen, you can see your definition has been created. Now it is time to add loads in this definition. And how you will do this, I'll show you. Just click on this create a definition and click on this add button. Different options. Suppose I am going to assign the flow loads. I have considered a dead load of 12 kilonewton per meter square on all floors and a dead load of 10 kilonewton per meter square on the roof. Similarly, live load, I have considered 4 kilonewton per meter square on all floors, and on the roof, I have considered 1.5 kilonewton per meter square. One thing, according to the IS 1893, if a live load is more than 3 kilonewton per meter square, then you will consider 50% of the live load while calculating your seismic weight. And if your live load is less than or equals to 3 kilonewton per meter square, then you will consider 25% of the live load. I'll show you the codal provision also. First, let me assign the flow weights. So I'm taking the value of the flow weights for dead load according to the dead load. 12 kilonewton per meter square. I'll assign the range. If I'll talk about the range, you can see from this floor to this floor, I'll assign the live load. So the range of Y range would be 4.2 to 10.6. 4.2 to 10.6. Add. Now I'll assign the live load on the floor. So the height of the building is, you can see here, 13.8. 3.2, 3.2, 3.2, and plus 4.2. So it would be 13.8. 13 point. So range would be 13.8. And close. Here you can see the flow has been created. Again, you will create the seismic weight for the live load. Go to this flow weight. As I have considered live load as 4 kilonewton per meter square. So according to the codal provision, we will consider 50% of the live load if it is greater than 3. So I'll consider 2 kilonewton per meter square. And the range would be 4.2 to 10.6 from this floor to this floor. And on the roof, we will not consider any live load according to the IS 1893. So this is how you will create your definition and you will assign the load on your structures. So let me share some IS codal provisions so you will understand it better.